LeetCode Problem number 787, cheapest flights within K stops. So this problem gives us n cities connected by some number of flights. We are given an array of flights where each flight would have their respective from, to, city, and the price it took. Right. So we are also given three integers, the source, destination, and K, and the goal is to return the cheapest price from the source to the destination with at most K stops. And if there are no such routes, we return -1. So basically, if you can look at this graph here in the example, let's say the source was 0, destination was 3. So we have to find the cheapest path with at most 1 stops. For this case, it will be 100 plus 600, right, 1 stop. If we were allowed 2 stops, if k was 2, then it will be from 0 to 1, 1 to 2, 2 to 3, right? We have 2 stops here. So knowing this, the approach I have to this problem is something I've just learned called the Bellman-Ford algorithm. So the first thing I do is I have the cost to reach the current node stored in a vector called dist. So at first you initialize to all to inmax, except for the starting source node, which is 0. That's what I do here. Next, I have a for loop. So this for loop will iterate through k times plus 1, inclusive of the starting turn, right? So I have a vector here which copies from destination, not destination but dist, and the copy is what we are going to use to modify during each k iteration. Afterwards, we will replace dist with the copy, just so that when we reference back, we don't reference too outdated information. So here I iterate through every flight. Let's say my first flight was from 0 to 1 at a cost of 100. So here I check, is this in max? No, it's not in max, right? So what I can do is replace the definition with the cost itself, which in this case is in max. The price it took to reach this node, which was 0, this as in the 0 node, plus the cost it will take to reach node 1, which in this case is 100. Okay, so the minimum between these two numbers, between inmax and 100, would be 100. So once that is done, we loop through the next flight. But for this case, if you see, this flight 1 is not registered yet in the dist, right? It's in max. So this if statement will not run. Same goes to all the other flights behind it. So technically we can just skip past all these flights, replace distance with copy, and now we move on. Okay, before we move on, so let's have an understanding of what just happened. So if k were to be 0, meaning that we would have no stops available, we could only reach the node 1 at a cost of 100, right? That's what was given to us. So if you look briefly over here in the return, since this, in this case, if let's say this was 1, this is not in max, right? Since this is not in max, we can return the price. But since this is 3, so if you see here, 3 is in max, meaning that we have not reached this city yet, which means we will return -1. Anyway, since k is 1, we allowed one more turn, so let's see what happens. So again, we create a copy from dist and iterate through every flight again. On this flight, since this is not equals to in max, right? It's not equals to in max, so we calculate the cost to reach the destination again. Minimum of copy flight 100 with the cost to reach here, which in this case is 0, plus the flight. So in this case it will be the cost of the flight 100. So this will be the same. The minimum of two equal values will be the same, 100. Let's skip this. Let's go next. Now for this specific city, we have reached here, and we know that the cost to reach where we are is 100. Since this is not in max, which we have reached it, so we are good to replace the destination node. So in this case, the destination is 2, 0, 1, 2. So here, specifically this one, we will compare minimum of in max with the cost to reach where we are, which is 100, plus the cost to go to where we want to go, which is 100 as well. So looking at this, the cost would be 200, and the minimum between these two values is 200. Okay, next we look at this flight. So for this flight again, we have not reached this node yet, 0, 0, 1, 2. We have not reached this node yet, so we can't do much about this. But for this one, from city 1 to 3, since city 1 is a registered, we have reached this this city before, so we can calculate the cost to reach the next city, which in this case would be 3. So copy 0, 1, 2, 3. So for this one, we're looking at the minimum between in max and the cost to reach here, which was 0, 1, which was 100, and plus the cost to go to our destination, which is 3. So the cost of it would be 600, total of which would be 700. The minimum of both is 700. So when that is done, in this case, when that is done, the copy will be put into distance. So before we go further, let's see what just happened. So if we were allowed one stop, we can reach to node 2 and node 3, right? Over here and over here. And the cost of which would be 200 to reach node 2, right? 1, 2, and 700 to reach node 3 at one stop. 100 plus 600. So if we were to allow one stop and the destination is to be 3, so here when we return with 700 being the answer, right? 700 being the answer, since this is not an in-max, right? So let's see what happens when we are allowed 2 stops. So let's run this one more time. So if you were to run this one more time, look through the for loops. So this will stay the same. This will stay the same. But for this one, like 2, so everything is not in max anymore. So we can update this. So the destination of 0, this is 0. Obviously this is going to be 0, so we can actually just skip this flight as well. And let's take a look at this one. For this flight, from flight 2 to flight 3, from city 2 to city 3. So we update this to the minimum of 700 with the cost to get where we are meaning we are at city 2, and it costs us 0, 1, 2, costs us 200 plus the cost to go to where we want to go, which in this case is city 3, and the cost of which is 200 more. So total will be 400, the minimum of which is 400. And if we were, after this, the follow-up ends, copy would be printed into distance, into dist. I keep calling it distance, but it's not distance. And when we return, it will be 400 instead of the original answer of 700, because now we are allowed 2 stops instead of 1. So meaning we can go from 0 to 1 to 2 and to 3, which in total will be 100 plus 100 plus 200 is 400. Okay, so basically that's how the Bellman Ford algorithm works. That's all I have to share. Thanks.